Our ancient Earth was covered in an ocean of magma, but managed to avoid the fate that Venus had. This is according to a new study. Some people say that Venus is Earth's twin, just about the same size. Our ancient Earth was covered by a magma ocean, and the planet was more similar to our neighboring Venus. The Earth's early years, the planet was covered by a blanket of magma, giving rise to an incredibly toxic atmosphere. Scientists believe that our home planet at the time was more like Venus, which now has a toxic atmosphere where temperatures exceed 400 degrees Celsius. Kindly support my Patreon channel because YouTube has again demonetized my YouTube channel. I will be uploading at least 5 videos a day. They will be totally different from the videos that I have on my regular YouTube channel. I hope you'll find them interesting, and you'll find the Patreon link in the description box below each video. Thank you. A new study examined the history of our planet and the process it went through to get to be the heaven that it is for our life today. When rocky planets such as our Earth begin to form, they go through a process called accretion. It's where small particles begin to lump together and eventually towards the end they build up to the point where their gravity is strong enough to pull in larger clumps. These small bodies are known as planetesimals and are similar to asteroids and celestial bodies. The ancient Earth was covered in a magma ocean, yet managed to avoid the fate of Venus. Now, during the late Earth stages of accretion, as they draw larger bodies into themselves, huge rocks impact early planets, which released huge amounts of energy. And the last accretion impact came when a Mars-sized celestial body came crashing into our Earth, and that caused much of the early planet to melt. This melting left Earth in a blanket of magma ocean, which would have released hydrogen, carbon, oxygen, and nitrogen gases to form Earth's first atmosphere. Now, according to a new study, this early Earth atmosphere could have been rich in hydrogen, ammonia, NH3, and carbon monoxide, CO gases. And to understand why, the scientists involved in the study wanted to work out the chemistry of the early magma ocean. One of the scientists, Anthony Burnham, from the Australian National University, said, "We determined this atmosphere was composed of CO2 and H2O. Nitrogen could have been in its element form, N2, rather than the toxic gas ammonia, NH3. But what would have happened when the magma ocean cooled down?" Well, he explains, it seems the early Earth cooled enough for the water vapor to condense out of the atmosphere, forming oceans of liquid water like we see today. This would have left an atmosphere with 97% CO2 and 3% N2, and a total pressure roughly 70 times today's atmospheric pressure. Talk about a greenhouse effect, he says. The team then wanted to understand how Earth cooled down, whereas Venus, which went through a similar process when it formed, still remains boiling hot. And the answer, according to them, from their study, which is published in the journal Science Advances, comes down to a matter of distance. Burnham says the ratio of CO2 to N2 is strikingly like the present atmosphere on Venus, so why did Venus, but not Earth, retain the hellish, toxic, hot environment we observe there today? The answer is that Venus was too close to the sun. It simply never cooled down enough to form water oceans. Instead, the H2O, the water in the atmosphere, stayed as water vapor and was slowly but inexorably lost to space. But on our early Earth, the water oceans instead slowly but steadily drew down CO2 from the atmosphere by reaction with rock. So although both planets started out almost identically, it's their different distances from our sun that put them on different paths. Earth became more conducive to life, while Venus became increasingly inhospitable. This is on Express UK by Sean Martin. Please leave your comments. Thank you.